Hello and welcome to another Mayday Academy training video. I am Marie, I'm a firefighting instructor at Mayday Academy, where we do maritime safety training for sailors on ocean-going ships. In this video, I want to discuss footage of a real-life fire attack, which did not take place on a ship, as you can clearly see, but ashore. But there is not so much footage of fires on ships, so we must use the ones available. But in the end, firefighting, if it's a ship, if it's ashore, the process of firefighting is basically more or less the same. Before we start, a short disclaimer. In this video, I will comment and analyze a real-life incident where firefighters successfully put out a fire, and of course I will mention what I think went well, but I will also, of course, when I see a mistake, I will also mention the mistake, because it's always better to learn from other people's mistakes than to make your own to learn from, which of course does not mean that I intend to blame anybody here. And yeah, it's very easy when I sit on my sofa and watch the video for the 5th time to see a lot of things which are not totally perfect. In the situation, when you are in there, it looks much different. You don't have time. Time is key when fighting a fire. You have to do your operations, you have to put it out. Of course, you will be nervous for a good reason, and mistakes just happen. They will always happen. What we want to do here is just help you to avoid mistakes, just about to show you, as future maritime firefighters and seafarers, how to put out a fire and what you need to consider. And again, many thanks to Ravenna City Fire Department, who kindly gave me the permission to use their footage on this video to help you to learn firefighting. So many thanks to Ravenna City. Okay, here we are. The engine arrived on scene, and you can see a garage fire fully involved where they have been called to. The hose is already stretched, as you can see. The fog nozzle is lying there. And now let's have a look at the fire together. Okay, first what they do here is the firefighter at the nozzle instructs their, on the ship we would call it a water team, ashore in Germany it would be the hose team. I don't know how they are called in the US. The ones responsible for the hoses, and they tell them to stretch out the hoses properly, because you don't want to have any kinks or sharp bends in the hose, which will actually block your water flow and reduce your pressure at the nozzle. Okay, what we can see here first is that the roof is on fire. I mean, the roof is totally involved. There is obviously a lot of heat inside this structure, and yeah, before we go in or before we even get close to there, we should do our assessment about the hazards on the fire ground. So I will ask you to pause this video for a moment and ask you, please put your ideas down in the comments. What hazards do you have to expect here before you go on with firefighting? Okay, see you in a minute. Okay, so what did your risk assessment What's the result of your risk assessment? So I will just see here what came to my mind when I had a look at the video. I mean also the later parts, because I already know what will happen. Okay, to assess the hazards involved in the operation, I went through this hazard matrix, which we use for assessment and for CSAP, but also of course for training purposes like this here. So let's go through it. Do we have a chance of toxic gases? Yes, we definitely have. I mean, where is a fire, there is smoke, and smoke is toxic, so we can almost always tick this off when there is a fire involved. Anxiety reaction. I would give this a no, because there seem not to be any civilians involved. So, I mean, firefighters could also show anxiety reactions, but in this routine situation, it's less likely. Fire spread. Yes, fire spread is a risk, because we have exposures to both sides, at least, the two garages, but we also don't know what is behind the building that could also catch fire. Nuclear hazards, probably not. Chemical hazards are possible, because it's obviously a garage or a workshop, so there might be certain things stored, used for the work, that might pose a chemical hazard. Collapse, yes, definitely. We have a wooden structure, the roof is damaged by the fire, so the whole thing could collapse. And there is also a suspended car inside, which possibly could fall down due to the fire, so there is a risk of collapse. Electrical hazards, probably yes, because it's a workshop, and in a workshop you need electricity. Probably we have the normal electricity of like 110 volts in the US. In Europe it would be like 230, but we might also have the high amplitude electricity system for welding and other purposes. Explosion could be because in a garage there might be pressure vessels or gas cylinders which might contain flammable gases for welding, for example. But even if it's non-flammable gas, then there is a risk of bursting of these cylinders, which I would also count as an explosion for practical purposes. And the last one, drowning, no, obviously not, because there is no water involved. Okay, now that we know all the risks and that we know that we will have to wear our SCBA sets, let's go on and see what they do about it. So we see the garage door is widely open. That's why we have a lot of visibility in the room. They're donning their SCBA. Normally in a structure fire, when you go inside, you will see much less. It will be totally dark. You will only see maybe the glow of the fire, but that's it. But here, because we have this wide ventilation opening, we can see a lot what is inside, which is lucky. Yeah, now they start applying water, and have a look at how they do it. So they first start putting a high flow rate under the roof with a solid stream or a straight stream. It's not solid because it's a hollow stream nozzle, so it's a straight stream. And we first put out all the fire under the roof. This is very important. Yeah, you would never want to pass under a burning structure like a roof, because first there's a lot of heat radiating down on you, which you don't want, and second, there is an increased risk of a collapse. Yeah, so you want to make sure to first put the fire out as far as you can in the structure above you before you get in anywhere. Okay, here, when I discuss this video in my course, students usually ask, why is this guy trying to go through the door? Why can't they go to the garage door, which is widely open? So maybe stop the video for a sec and put your ideas down in the comment if it's a good idea to go through the door, or if they could just easily pass through the garage door. Okay, so of course I don't know what you comment because I'm still recording, but I think it's not a bad idea to try the door first, because the garage door is like half open, and I guess they are afraid of the garage door falling down on their head, or even cutting their hose when they're inside. So I think it's a good idea first to try the proper door before going under a potentially hazardous, damaged garage door. Okay, they try to get in. They can put water in. And yeah. Now the colleague comes to help and trying to smash the door, or trying to secure the garage door first, but yeah, obviously it doesn't really work. Okay, so now they change their mind and decide to get in through the garage door. I mean, this is something you must always evaluate on a case-by-case basis. Yeah, I cannot tell you like it's wrong what they do or it's right what they do. I mean, they did it, they were successful. There is always risk involved. The risk would have been lesser if they would have opened the door. On the other hand, you would have lost a lot of time opening the door. So they did what they did. And here again we see that they extinguish the fire first close to the door, because you don't want to pass by an active fire. Yeah, you don't never want to have the fire besides you or even behind you. That would be very bad, because it could cut your way out actually. And what you see here, this stream that you can see here, it's a solid, or it's a straight stream. Usually what we teach is to never use a straight stream inside, inside a structure when you are in an internal attack, just to have better gas cooling abilities of the water and to prevent excessive steam production. In this case, however, I guess it's okay, because you have this very large opening of the garage door, so steam can easily get out. There is no overpressurization of the room. And the advantage of the solid stream here is that it gives you much more impact on the burning structures, so the water can penetrate much better into the structure of the solid fuel than a spray stream could do. Yeah? So for overhaul or for extinguishing glow spots in solid fuel, a straight stream is a perfect choice. And watch how they take care of the ceiling first. And what we can see here when we look at the water, this is clearly a water nozzle. That's a normal hollow stream nozzle or fog nozzle. But what comes down from the ceiling looks like foam. I guess what they did here is they added foaming agent into their extinguishing water just to make it penetrate better into the fuel. Yeah, when you have a solid fuel where you want the water to get inside, where you want the water to penetrate into, this is what you can do. You can mix foaming agent into your extinguishing water, like 1% or 2%, which will reduce the surface tension of the water and make the abilities of entering the structures better. And also the water coming down here will form a foam blanket on the floor, which prevents any potential spillage of petrol dripping down from this car from igniting. So what they're doing now is just getting stuff out of the fire site, yeah, which of course is a good idea. Yeah, when you are somewhere and you don't necessarily need all your effort to fight the fire, then it's a good idea to get rid of any stuff lying around, smoldering stuff, which reduces the fuel load in the room. Yeah, when you take it out, it cannot burn inside the structure anymore, and also makes your life easier because you cannot stumble across it or whatever. Okay, minute 4:02, go. Yeah, here we see a very bright flame. When you have a look at this flame, it's much brighter than the rest of the fire, and obviously there is not so much a point in putting water on it, because it doesn't go out, it even gets brighter. So just please think about it. What could it be? Why does this fire not react to water, or not react in the way we want it being knocked down? So they gave it up for the time being. They continue elsewhere, take care of the car, while thinking about what to do about this very bright fire in the corner. So looks like discussing the garage next door. Of course, when you have a space adjacent to the space on fire, it's an exposure, meaning that the fire can spread to this space. Yeah, we call it an exposure when it's at risk of being involved by the fire. And yeah, later you will see that probably they instructed their colleague to get an entrance to the garage next door. Yeah, they can't open the garage, so for the time being, they continue in the fire compartment. By the way, the fire in the lower right corner, it's a bit, I find it a bit annoying. It's a bit like against my sense of aesthetics, at least, that they don't put it out. Yeah, normally you would just take the 2 seconds and put it out and not pass beyond the fire, but yeah, it's a minor detail. Yeah, now they cut the door because they couldn't open it, and now we can have a look inside. What's inside there? And I mean, they were right, there is already smoke, so the fire's already progressed into the room next door. Okay, again, we are again at this super bright flame. Now they're trying with a fog pattern, with a narrow fog pattern, to have more cooling effect. Ah, finally they put this one out. I waited for this all my life. And now the bright one. So, don't know if you already guessed what this is. What is it? Like, it's burning, and when you put the wet stuff on the red stuff, then the red stuff will turn into yellow and then white stuff, which is not exactly how we wanted it to go. Yeah, it's super bright, which means it seems to be super hot. What do you think this is? Okay, I just give the solution. This very much looks like a metal fire, yeah? I mean, metal can burn, especially when you have a dust of metal, especially if it's alumina or some certain materials tend to burn when you have, for example, grinding dust in a workshop. Yeah? Which means housekeeping is key in a workshop. Yeah? Never let your grinding dust lie around everywhere. It's a fire risk. When you want to fight this fire, you can't do it with water unless you use extensive amount of water. The reason is that metal fires burn super hot. And what will happen when you put water on a metal fire with like a couple of thousand centigrades burning temperature? The water will thermally dissociate. Thermal dissociation means that by the heat, the water is split up into hydrogen and oxygen. Yeah? Water consists of 2 hydrogen atoms and 1 oxygen atom. And when you split it up, you have a mixture of hydrogen and oxygen, which is explosive and highly flammable. So when this hydrogen and oxygen travels out of the very hot zone, cools down, it starts reacting again. Yeah, it changes its mind, it wants to be water again, and sets all the energy free that it took from the fire before, but it doesn't do it in the fire where it started, but elsewhere. And the effect is that you will just spread the fire reaction, spread the combustion to other places. That's why the flame appears to be so big, because the hydrogen and oxygen mixture travels up with the airflow and then reacts again, making another flame above the original flame. So the solution would be either to use a special D-class extinguishing powder. There are powder handheld extinguishers with the so-called D-class powder. Yeah, fire class D is burning metal, at least in the European and Australian system. And there is specialized class D extinguishers for that purpose. If you don't have one at hand, you can also use any inert material. Inert material is a material that itself doesn't burn, so you can use sand or dirt or whatsoever to bury the fire and then cut it off from oxygen. Yeah, that is why on many ships in the engine room we have a sandbox exactly for that purpose. Okay, so much about this case video here. I hope you found the discussion useful and it helped you improve your skills in maritime safety and maritime firefighting. So, yeah, have a nice time, stay safe, and see you next time. Bye bye!